So here we are again solving rational inequalities. In the last video we solved these two inequalities, and today I want to solve a little harder one. I'm going to solve this one right here. The basic game plan is to move everything to one side, determine where that function on that side is 0 or it's undefined, make a number line and make a chart, and then fill out our answer. The problem I want to do today is 3x minus 3 over x plus 2 is less than or equal to 2. The first thing I see students do when they want to solve a problem like this, and it's quite natural, is to multiply both sides by x plus 2 to clear out the fraction. And then you could solve it, theoretically, as a polynomial inequality. However, you can't do that. And here's the reason why. When you multiply both sides of an inequality by a negative number, you reverse the orientation of the inequality. But if you multiply both sides by a positive number, you don't change the direction of the inequality. The reason why you can't multiply both sides of an inequality by a variable expression, something that has an x in it, is that you don't know whether x plus 2 is positive or negative. So you don't know whether you should flip the inequality. So it's going to take a little bit more work. All right, so we're going to move the 2 to the other side by subtraction. Now everything's on the left-hand side. We want to write this as a single fraction, and then we can treat it the way we did the rational function in the last video. We can factor the numerator, factor the denominator. Alright, so we've moved the 2 over, and now we want to write this as a single fraction. We're going to write 2 as 2 times x plus 2 over x plus 2. So we just multiplied 2 by 1. Then we can combine both fractions as one fraction over a single denominator, x plus 2. Distribute that negative 2 on top, so we get 3x minus 2x is x, and negative 3 minus 4 is negative 7. So that's the left-hand side, just x minus 7 over x plus 2. A fraction is 0 only when the numerator is 0, and it's undefined when the denominator is 0. So this fraction here is 0 at x equals 7, that's when the numerator is 0. And it's undefined at x equals negative 2. All right, those are the numbers we're going to plot on our number line, negative 2 and 7. So we make a number line, we plot negative 2 and 7. Here's my original inequality up here at the top, well, the new form of the original inequality. And I'm going to make a chart next. Those numbers, negative 2 and 7, divide my number line into 3 intervals. Negative infinity to negative 2, negative 2 to 7, 7 to infinity. We pick a test number from each interval, plug it into our left-hand side, and see if we get a positive number or a negative number. The numbers I chose as test numbers are negative 3 for the first interval, 0 for the second interval, and 8 for the third interval. When I plug, for example, x equals negative 3 into the left-hand side, I get negative 3 minus 7, which is a negative number, over negative 3 plus 2. Again, a negative number. A negative over a negative is a positive, and so I put a plus over that first interval. When I put 0 in to the left-hand side, I get negative 7, which is a negative number, over 2, which is a positive number. A negative divided by a positive is a negative. And finally, when I put 8 in, I get a positive over a positive, which is a positive. All right. Remember, we're looking actually for the negatives because we're solving x minus 7 over x plus 2 is less than or equal to 0. So we're going to want the negatives, and we're going to have to decide about the endpoints, the negative 2 and the 7. Since the left-hand side is 0 at 7, we want to include that in our solution. Since the left-hand side is undefined at negative 2, we cannot include negative 2 in the solution. So the solution is negative 2, round bracket, to 7, square bracket. Okay, and that's it for inequalities. I hope this has been helpful. Bye-bye.